Welcome back to our General Awareness course on the transportation of dangerous goods regulations. In this module, we will discuss means of containment for dangerous goods. We'll start this module with a refresher. A means of containment is any container or packaging, or any part of a means of transport, like a truck or train, that is or may be used to transport dangerous goods. And a large means of containment is one with a capacity greater than 450 liters, while a small means of containment has a capacity less than or equal to 450 liters. Refresher aside, you cannot transport dangerous goods unless they are in a means of containment that is designed, constructed, filled, closed, secured, and maintained, so that under normal conditions of transport there will be no release of the dangerous goods that could endanger public safety. While there are many different standards for means of containment, one common group is the UN Standardized Means of Containment. In these cases, the means of containment must have the applicable UN mark and comply with one of several standards. 43.125 if they're infectious substances, 43.146 for intermediate bulk containers, 14.850 for small containers, or the UN recommendations and national regulations of the country of manufacture if the means of containment was not made in Canada. Now you may have noticed that I slipped in a new term in the last slide, an intermediate bulk container. An intermediate bulk container is a rigid or flexible portable means of containment that has a capacity equal to or less than 3,000 liters and is designed for mechanical handling other than a bag, box, drum, or jerry can. At 3,000 liters and less, it crosses the line between small and large means of containment. There's an example of an intermediate bulk container on the slide. As you can see, it is not a bag, box, drum, or jerry can, but it is a means of containment designed to hold larger quantities of dangerous goods. I mentioned the UN marks were needed for a means of containment to qualify as a UN standardized means of containment. So what do these marks look like? Such marks have a set format. The first line looks like number A/A number/A, where A represents a letter or series of letters, and number is a number or series of numbers. The line is read as packaging type, packing group or density, solids and pressure rating, and year of manufacture. The second line looks like AA/AA number, where the first letters are the country of manufacture and the last letters are the manufacturer's code. Now that was very complex and abstract, so let's look at an example on the slide. In this case, the markings are read as 1, the UN symbol means it is a UN standardized means of containment. 4 means it is a box. G means it is made of fiberboard, or more commonly called cardboard in Canada. Y is the performance level, indicating the box was successfully tested to the packing group 1 or 2 level. 14 is the gross mass the box is designed to hold in kilograms. S means it is designed to hold either solids or liquids that are inside a smaller means of containment, like bottles or bags. 23 is the year of manufacture. And on the second line, USA is the country where it was made. M4563 is the code for the manufacturer. A whole bunch of information in one little code. As I noted before, the UN standardized means of containment are not the only group of means of containment. Thus, we have marks corresponding to the other standards. Here, for instance, is a marking from my home barbecue tank. Apologies for the difficulty in reading the embossed markings. But looking closely, the DOT on the first line means it's certified in the US. The TC on the second line means it is certified by Transport Canada. 4BA, common to both countries, means it is a cylinder, either spherical or cylindrical in design, with a water capacity of 1,000 pounds or less and a service pressure of 1,500 to 3,400 kilopascals, or 225 to 500 pounds per square inch. The 240 on the top means it is designed to hold 240 psi, an American unit of measure. This is equivalent to the 16 bars on the bottom line used in Canada. Now, it stands to reason you would not overfill a container. And in cases where a standard does not tell you what the design capacity is, you must follow the manufacturer's specifications and ensure the means of containment could not become liquid full at any temperature that is less than or equal to 55 degrees Celsius. And what is liquid full? Thinking back to high school science class, most liquids expand as the temperature rises. What we mean by liquid full is that, as the temperature goes up to 55 degrees, the liquid's volume will never exceed the container's volume. While the transportation of dangerous goods regulations do state which standards must be used when, it is somewhat confusing. Thus, we prepare the table on the slide, which is also in your participant's guide, to show you which standard to use when. This table is for gases. When transporting non-gaseous dangerous goods in a small means of containment, the means of containment must meet either 43.146 for intermediate bulk containers or 14.850 for other small containers. And for large means of containment, this table lists the relevant standards. And all three of these tables are, as I mentioned, in the participant guide. Some of these means of containment are quite expensive, thus you may be tempted to reuse them. But there are limits. For drums equal to or more than 150 liters, or 33 imperial gallons, the drums must be reconditioned before reused to transport liquids. And intermediate bulk containers that store dangerous goods under pressure must be leak tested and inspected before reused to transport dangerous goods. Note that this applies only to transport. You're free to reuse drums and intermediate bulk containers on site for any safe purpose you want. The regulations also require that the manufacturers of most small means of containment give you some help, in this case in the form of instructions. So far I've dealt with general rules for means of containment. While I will not discuss them here, I will note that there are specific requirements for railway tank cars, infectious substances, and consolidation bins. I leave it to you to review the special requirements that apply to you. This discussion has been very theoretical and probably quite boring so far. So I want to bring some of the concepts home with an example. Suppose you are shipping 427 full 10-liter containers of methanol from your office to your house. Each box has a mass of 12 kilograms. Can you transport the methanol in a plastic bag inside a fiberboard box, like a wine box? Remember Schedule 1 from our second module? Well, here it comes again. Looking at Schedule 1, we see that methanol has a primary class of 3, a subsidiary class of 6.1, and is in packing group 2. We also know we are considering 10-liter boxes. At under 450 liters, these are small means of containment. Going back a few slides, a small means of containment for a Class 3 dangerous good must comply with either 146, design and manufacture of intermediate bulk containers, or 14850 for other small containers. Noting that we are talking about boxes here, and also remembering that the definition of intermediate bulk container does not include boxes, we cannot use the first standard. Thus, we are left with using TP 14850. At this point, it would be good to open up a copy of TP 14850 using the link on page 34 of the participant guide. So now that we know we have to use 14850, where do we go from here? Similar to the Transportation of Dangerous Goods regulations, 14850 also has a list at the back. This time called Appendix A, it gives packing instructions and substance-specific provisions for a range of dangerous goods. And the first page of Part A in that appendix includes dangerous goods of Class 3 and Packing Group 2 and 3. And as we see in column 4 of the slide, this applies to any subsidiary class. And what does this table tell us? It says in the far right-hand column that we must follow Packing Instruction 2. So off to Packing Instruction 2, which is found in Part B of the same appendix we just used. And this is what Packing Instruction 2 says. The dangerous goods must be transported in a combination packaging comprising a glass, plastic, or metal inner packaging and an outer packaging, which is one of those listed codes, a single packaging, which is one of the listed codes, or cylinder or sphere. And the maximum capacity or net mass of the inner packaging must be less than or equal to 10 liters for glass, 30 liters for plastic, 40 liters for metal, and the outer packaging or single package must be equal to or less than certain maximums, capacities, and masses. Now remember, we are thinking of a plastic bag of methanol inside a fiberboard box. This is officially called a combination packaging, one or more inner packagings contained in an outer packaging for transport. We are thus not talking about 1B, which is single packaging, or 1C, which is cylinders or spheres. So 1A it is. Simplifying the first part of Pack Instruction 2, we get this slide which specifies a glass, plastic, or metal inner packaging, which we have since we are using a plastic bag, and an outer packaging that has one of the listed codes. And what is the code for a fiberboard box? From Table 1, again of the standard 14850, we see the code is 4G. And you see that such boxes have a maximum capacity of 400 kilograms. Since our boxes hold 10 liters of methanol, or roughly 10 to 12 kilograms, we are well below the maximum. Back to Pack Instruction 2, we see that 4G, a fiberboard box, is indeed a valid packaging. And just one more detail. Clause 2. We already said that our methanol bags are 10 liters each, well below the 30-liter maximum in Clause 2A. And there you have it. Yes, according to TP 14850, we can transport methanol in 10-liter plastic bags enclosed in a fiberboard box. But 427 10-liter boxes will not fit inside my Hyundai Tucson. I will need a transport truck. Are there any specific means of containment standards for the truck? Here we get a trick, but a useful trick, and a reason to read the entire regulation. Section 1.32K of the regulation says, when the words means of containment are used, they refer to the minimum required means of containment. The regulations simply say the means of containment must meet TP 14850 without further defining what means of containment means. Thus, we're talking about the minimum required means of containment. That is, the innermost container needed to hold the dangerous goods. The minimum required means of containment would be the box, not the truck. Thus, the truck does not have to meet any means of containment standard, although it may still have to be placarded. And that concludes our discussion of means of containment. I invite you now to move on to Module 7, where we will discuss emergency response assistance plans and reporting.